Welcome to Click My Project. Our project title is Efficient and Consistent Path Loss Modeling for Mobile Network Simulation. Let us see the abstract of our project. The accuracy of the wireless network packet simulation critically depends on the quality of the wireless channel models. Path loss is the stationary component of the channel model affected by the shadowing in the environment. Existing path loss modeling or inaccurate required excessive measurement or computational overhead and often cannot be made to represent a given environment. In this project, contribute a flexible path loss modeling that uses a novel approaches for spatially coordinates interpolation from the available nearest by the channel to allow a accurate and efficient modeling of path loss. We show the proposed model called a double regression, generating a correlated space allowing both the sender and the receiver to move without the channel in the path loss. Combining the DR with the traditional temporal fading model such as a relay light fading, providing an accurate and efficient channel model that we integrating with the MST simulator. We using the measurement to validating the accuracy of the model for a number of scenarios. We also show that there is a substantial impact on the simulation behavior when path loss is modeled accurately. Finally, we show that the unliking statistical models and DR can make a simulation representation of a given environment by using a small number of seeding measurements. Thus, DR provided the cost-effective alternative to ray tracking or a detailed site surveys. Let us see the flow of our project. First one is a network formation. The network formation containing the 13 nodes. The simulation work has been done within the network simulator NS2 version 2.34. The network formation is an aspect of creating the nodes of network and transmitting data. The network of 13 nodes is a dynamic creation using the network simulation for wireless network. Then next one is an position finding. The each and every node position and the distance is calculated here. Then finding the neighbor discovery algorithm. The neighbor discovery algorithm is used to finding the neighbor of the node. On demand reacting protocol that uses a routing table with the one entry per destination. When a source node needs to finding the routing to the destination, it starts the route discovery process based on the floating to locating the destination node. Upon the receiving routing request packet, intermediate node updating their routing tables for a reverse routing to the source. Similarly, the forwarding routing to the destination is updating upon the reception of the routing replay packet oriented either by the destination itself or any other intermediate node that has a current routing to the destination. Then finding the member of the node. This is a security analysis. Then if it is a member of the node means sends the communication, otherwise it will not allow for finding. The finding the optimal path algorithm is an optimization algorithm used to use a proposed method for constructing an optimal path for transmitting the sensed data to the destination. The nodes which has the data to the transmitting is called the source node. Such the node checker for the next best hop to the transmitting the sensed data towards the destination. For finding the next best hop, a routing request messages is sent to all the neighbors. The routing request sends to all the intimated nodes between the source and the destination. The security packet for an encrypted data packets and using the hash function for identifying the varying the length of the digital signature scheme for authentication. If the authentication is successful, then it sends the packet through the reliable routing path. In our scheme, the intermediate nodes performing the patch verification with the nodes of signature and cybertext receiver from their member of the node. The aggregated of the cybertext and the signature generating the aggregation of cybertext without the decryption of the cybertext. Hope by hope authentication is here. Then finding the performance measures. A difference network parameter analysis is being done for a proposed method. Then parameter like the total energy consumption, throughput, packet delivery ratio and delay are calculating for the proposed protocol. Let us see the output of our project. This is a virtual machine. First open the terminal window. The root local host is a root home. So now I change the root directory. Our project coding folder is code. So I type cd space code. This command is used to change the directory. So here change the root into code. Then I type the ns space main.tcl. This command is used to run the project. Here calculating the routing of the project, finding the next best hop after routing. This is an optimal path algorithm. This is a NAM console. Then this is a NAM output NAM window. This is on a rewind button. This is playback button. This is stop button, and this is play forward button. This is fast forward button. Then this is a time simulation and a speed setup. Now I run the project. Here I deployed it at 30 nodes. Source and destination is created. Neighbor node is estimated and the communication start. The communication 6 is sent to the 5th node, sends communication to 5th, and finding the optimal path. This is not an optimal path of source to destination. So find the optimal path 6 to 17. So 6 sends a communication to the 3 sends communication to 22, and 22 sends communication to 4, and 4 sends communication to the 17. The source to destination communication is end here. Here the security is verified. The sender containing the encrypted key and the receiver containing the decryption key. Then type finding the delay of our project. Comparing with an existing system, our project delay is decreases. Then type xgraph space thr.exe. This command is used to finding the throughput of our project. Thank you for listening. Demo is completed.